So we have two speakers. We have me, real quick, and then we have Kenny Bastani right here. If you guys don't know Kenny, he's former Neo4j. Like you were like an evangelist there, or / developer, I don't know, something. And now he's at like Pivotal Labs. Works for actually one of my friends, which I just found out. So yeah, he has a really good boss there, which is cool. Yeah, it's always good to have a good boss. I'm going to do some announcements and then go right in. I have some kind of just overview Spark stuff. I'm going to talk about Spark GraphX, Spark graph frames. One thing that I realized when I was at, like specifically Databricks, is people constantly wanted to use GraphX for pretty much all use cases, right? Like they wanted just to make it work for, I mean, right down to like autocomplete and right, like scenarios where people are trying to type Starbucks and they do K instead of CK and things like that. And I was talking to Kenny about this offline the other day, and yeah, like he'll probably talk about it more. But that's a huge no-no, right? These are graph analytics tools. GraphX specifically is meant for sort of offline batch graph like processing, and then that's sort of like an overall theme I found with Spark. I've mentioned this before, but people tend to use Spark for pretty much everything, right? Like they want to like treat it like an app server, like a database, or like a graph database, super high throughput streaming, like things like that. So just kind of pick and choose what you're going to use Spark for, and yeah, right. Like just don't forget about MySQL and some of the old standbys that we have that work pretty well and like have been working. So a few quick announcements. I'll go through my spiel. It should be about 20 minutes, and then Kenny's going to steal the show and talk about whatever Kenny talks about. I think, right, like you've done this presentation before with, at Docker, a couple months ago. So, all right, let's just get right into it. I've got some demos also. I just recently converted everything over to graph frames, which, if you guys haven't heard, it's kind of, it's a Spark package right now, which is kind of a 1.5 class citizen of Spark. It's not part of the actual Spark core, but if you can sort of infer and like take a look beneath the covers, they're actually using some of the developer APIs, which is always a big no-no, right? The guys at Databricks always say, don't do that. So the fact that they're relying on it, and if like you can kind of put this together, right? Like Databricks is speaking on this at conferences. They're like presenting it like on like Databricks official webinars. So there's a pretty good chance that this is going to make it into Spark 2.0. So I'll talk about it in a sec, but graph frames right now just basically delegate out to the old GraphX. So it's kind of a little switcheroo maneuver. Makes you think that you're actually like using like data frames beneath the covers, but you're actually just wrapping for the most part. There's a couple of native graph frame like algorithms that I should get into. So let's see. Oh yeah, and then down in Palo Alto, the last meetup that we had, I've officially changed the name to also include TensorFlow, and this is sort of beyond just like staying on top of trends and like things like that. There's a whole ton of really good patterns. If you guys haven't seen the actual TensorFlow like white paper that came out, I think in like November, there's like tons and tons of like good patterns in there for like distributed machine learning, for training, for the serving layer, which is like the prediction layer, things like that. So there's an upcoming meetup. I think I just added it last night. May 26th, I'm planning it. People are coming into town. A guy from like LA who is a like TensorFlow expert. It's sort of hard to find these guys beyond like Google right now, and I've reached out to Google, and I mean those guys are super busy, right? So I think someone actually spoke here at the Data like Eng conference. Did anyone go to that? It was a couple weeks ago. Yeah. Oh yeah. By the way, do you want to like say any announcements or anything? No, not yet. Yeah, that's like slide number 3 here. Oh, okay. Let me get to, I think you guys know me by now, former Netflix, Databricks, currently IBM. I've got this meetup here, so, and then,
cool.
Yeah, go ahead.
Yeah, my name's Jared. I'm one of the organizers of the SF Data Science Meetup, and it's always a pleasure to have Chris here. He's the man. We have an awesome workshop by Chris this Saturday. Chris can tell you more about it. I'm sure he will in just a second here, but it's going to be a lot of fun. I think there are only like less than 10 spots left.
Oh, really?
Yeah,
I love
I
that.
think less than 10 spots. We already have 75 tickets sold. We've got about 20 galvanized students. Some of them are from the data engineering program, some of them from the data science program who will be attending. In case you don't know, that's what Galvanize does. You're at Galvanize right now. It's not just a co-working space. We train data scientists, data engineers, and web developers in short, immersive programs. So it's very much a full-time, immersive learning experience. And we help them go from soup to nuts into data science and go into industry. So that's kind of what we do. And my role here, I'm a developer evangelist. So I teach intro programming classes, and I work with the data science team and our web development team. So if you ever have any questions about Galvanize, our programs, or if you ever are interested in teaching a workshop at the Meetup, or if you're ever interested in speaking at the Meetup, or just getting involved or TAing, we'd love to have people involved. So feel free to email me. It's just Jared. It's Jared, Jared like the Gallery of Jewelry, at galvanize.com. It's really easy to remember, trust me. I'm going to let Chris get back into it because he's going to tell you about the awesome workshop that's happening this Saturday. I hope I see you guys there. It's going to be really cool. So thanks, man.
Sweet, man.
Thanks, buddy.
Yeah, thanks, Jared. Yeah, so I finally got Jared to start responding to me on text message, which is kind of fun. I get to bug him all the time. Right, what's the count up to? How many pizzas do I need? Yeah, obviously, double the pizza. So quick update here. We just hit 3,000 members about 2 or 3 weeks ago. That was when I did the rename as well, the refocus. So I think the next 6 months, we're gonna sort of bounce back and forth between Spark and then TensorFlow. I'm actually gonna bridge the two. I'm building a ML serving layer that's modeled, for Spark, that's modeled, straight after the whole TensorFlow serving components. It's gonna have the exact same interfaces, servable and things like that. I think they're really good patterns. I'm gonna mix in my Netflix experience, Netflix has this project called Hystrix that's open source, that's a circuit breaker. So when you have multiple dependent services that are all calling into each other, if there's any latent service or one that's just completely down, it'll go into fallback mode. The main use case for this was for recommendations, personalization. If the personalization service wasn't available, it would just return just a generic top 10 list of movies to show, whatever. That would please the sort of higher ups. That would please the ops team. We technically had 100% availability, but not totally personalized. So I'll be mixing those two. Again, the number of Docker downloads that powers all these demos. This has been tracking, pretty much the exact same number as the members, which is kind of funny. Okay, thank you guys. I changed 3,000. I put the. No one got me a cake. Someone kind of brought a cake, but it was from Baskin Robbins, and it was this big and had some Oreos or something. So couldn't really write too much on it. But tomorrow night, this just happened to be where we have back-to-back meetups. Tomorrow night's going to be badass. We have 5 speakers. This is a mini conference. I'm actually not going to speak, which is nice. I'll be part of the Ask Me Anything probably afterward, but we have a committer coming. We have between 3 of the speakers, I think there's 5 Spark books that are currently in print, or I think one of them is about to be released that's in raw form right now through the O'Reilly guys. It's going to be focused on the internals. When I first created this meetup, this was the exact session that I pictured, because I think a lot of us know how to use Spark, but we don't really know the internals or how shuffle works and things like that. So I've got Mark Hamstra, I've got Holden, that you guys probably know with the crazy hair. I think, she actually wore a panda thing for Spark Summit, for her talk at Spark Summit. Let's see. Real quick, Pancake Stack. I was one of the original developers on the Smack Stack. I had to take it to the next level, and I had to incorporate Stack in there somehow. And there's a lot of A's here, so I think, Arrow, right. So I got into so much trouble for this because I didn't put Apache in front of everything, which I told the guys, I'm it would just be steak or stack, right? It would just be a bunch of A's. If you were at Strata, I was plastering this everywhere in the bathrooms, and they kept tearing it down as quickly as I could put it up. It was kind of funny. People were tweeting about it. Sorry. So I actually lost one of my really good friends this week, and I've been a mess. She was 40 years old and just we still don't know what happened. We're still getting information, but so yeah, I'm a little choked up here. But yeah, the A's are for Arrow, Airflow. Yeah, we've got Algebird. We have Core NLP, NiFi. Yeah, we'll talk about Elasticsearch, right? Like, of course, Kafka, right? Like, do people use Kafka here? Yeah, so who doesn't use Kafka, I guess, right now? Yeah, so I'm curious, what do you use if you don't use Kafka? Yeah, right, like, do you have any streaming stuff going on right now? You? No? Okay. Starting to see Apex too, which I guess would fit in here pretty nicely, because yeah, there's a bunch of A's, but waiting to see how that stuff unfolds. I saw a really good talk by the Flink guys at Strata. They are from Berlin, and they have this kind of German sense of humor, and I think some of the Apex guys felt left out because, you know, right, they're talking about Spark streaming, they were talking about, right, yes, all the other really common ones, and they kept forgetting Apex, so. Okay, just real quick, my stuff's not that deep. Yeah, Kenny is the graph man, so I'm just gonna blaze through these. Who here knows that like Elasticsearch, right, like just released a right, like graph component on top of Kibana, right? So yes, I didn't realize this, but like Kibana has kind of become their right, like sort of platform for right, like all visualization stuff. So they have a bunch of plugins. They have this plugin called Sense, where you can actually run right, like REST API calls against Elasticsearch, against the indexes. They're sort of getting into the graph space, which is like sort of interesting because that's the same thing that Titan with Cassandra, right? Like DataStax just bought the Titan guys, I guess, some kind of developer buyout maybe. So I think what was going on there, just based on sort of rumor, is that right, there were so many clients that were using both of those technologies together that they finally realized that it's time to really put them together and then optimize it. This is Titan and like Cassandra. Of course, Neo4j. Yeah, I'll let Kenny talk about that. That's his jam. GraphX. So I sort of on the left side put right, like graph databases, things that you might want to put on the user request hot path, you know, right, like autocomplete or putting recommendations there, right, like graph-based recommendations. These things on the right, you definitely do not want to put these on the user request hot path. There's a lot of stuff going on there. These things require the entire graph, typically, right? Think of the incremental PageRank like sort of use case where you just want to update small bits of the graph. I think right, like some of that stuff is coming specifically to GraphX. I don't know too much about Giraffe, but and then there's this Python like library called NetworkX. Has anyone used this? Cool. Yeah, this is actually pretty powerful. So if I have time, I'll show a demo, but these demos are all out there on GitHub off of it, like the advancedspark.com, where I take the Spark user list and figure out who's in the middle. And so basically I run about 4 or 5 different centrality measures, right? So there's different types of centrality, which I didn't really realize until I started getting into some of this graph stuff. So, and basically Mate is always at the center, and then like Michael Armbrust, the guy behind Spark SQL, is always there. All the typical guys that if you do watch the Spark user list, they're all there. Yeah, so pretty basic. Right, like one thing that was funny is that the Elasticsearch guys explained that they couldn't choose the term node for their vertices because node was already taken for like a cluster node, which I thought was kind of funny. Property graphs, this is a big Spark thing as well. Yeah, you can attach graph or like properties, basically like hash maps to these like vertices. You can filter based on them, that kind of thing. So the typical question is like, do you make it a property on the node or do you make it a whole separate relationship? So yeah, there's some pros and cons there. Maybe Kenny can talk about some of those, the ability to filter on things like that. Directed, undirected, edge direction, either both, right, like both directions. Yeah, typical stuff here, weighted, unweighted. This comes into play when you're doing things like Dijkstra, right, like shortest path between nodes. Yeah, so that's important. Yeah, of course, right, the adjacency matrix, all this stuff comes down to matrices at some point. So now this is actually, yeah, I wanted to point this out for the bipartite graph, because like this comes up quite a bit, especially with recommendations and things like that. Typically that's the diagram that you see, right? You have like the left side, you have you, and then you have V, that's like users or like items or videos, whatever. I saw this recently where it's sort of a 3D projection, right? And it kind of shows, you've got users up there, you have items down here, you have things going back and forth, but now you want to find similars on like each of those planes. So I think that does a really good job of showing that versus like sort of mucking up with that like two-dimensional view there. Yeah, trees are graphs. Complete graphs are a complete nightmare. If you have a complete graph, just give up. Yeah, find a new job. What was interesting is, yes, I did a lot of like graph training, like graph research out in DC. I've been traveling quite a bit. Like between here and there, there's this company, it's called District Data Labs, very similar to the whole galvanized model. They have like a little like sort of incubator space. And yeah, those guys know their graphs, and it like totally makes sense, right? I mean, they're trying to find terrorists or trying to figure out how often I call Domino's Pizza, whatever. But yeah, those guys know their graphs. So yeah, check out some of their workshops. I think I just heard about a call between Jared and the District Data Labs guys. I think there might be some like cross-pollination coming up here soon, where they're going to start offering classes and like cross-coast, where those guys will come out here and teach. So yeah, definitely look out for that, because those guys know their stuff. They're all PhDs from like Maryland and that kind of thing. I guess this is sort of a different view of the same. Yeah, GraphDB, that's what you want to put online. Yeah, Graph Analytics offline. I discovered System G. Yeah, by like IBM has to put system in front of everything. I just discovered this. Yeah, actually this morning I was like updating the slides and I'm like, System G. So yeah, we have System ML, we have System T, which is internal. It's for like customers only. That's the like sort of NLP text processing. And then we have apparently this huge GraphNet like library that like no one's ever heard of. So yeah, now you've heard of it. I tried to download it and it was going to make me sign all these waivers and give away my life. And yes, I worked there and I was scared to fill all that stuff out. So what's interesting, and yeah, Kenny, right? Like you're going to talk about this, right? Yeah, where did Kenny go? There's this project Maze Runner. This is actually, I think, when I first heard about Kenny, right? Where yeah, he's sort of mixing these two models. So taking transactional Neo4j data, right, pulling it in to Spark, processing it, and then putting it back, right, like into Neo4j, right? Is that kind of the, okay. Yeah, do you want to say anything?
ETL process.
Yeah.
And also over it in depth. Yeah.
Got it.
With diagrams, that'd be nice.
Yeah, so he has like Docker, just crazy Docker images already and like set up. You can just like fire up a few commands and everything works right away. So that's really cool. Visualization, I've been spending a lot of time with Matplotlib recently. I'm sort of making this slow transition. I don't know about you guys, but when I first started using notebooks, I went straight to Zeppelin just because it's a sweet name and yeah, it has a cool logo, and I didn't really, I didn't want to associate myself with Python at all. Yeah, so I actually kind of like Python. Like so I'm building this serving layer, right, like for Spark ML. And man, it's just, there's so much less code and, yeah, like it might be a little bit sloppy and I can't really figure out how to write tests or anything, but yeah, I mean, who needs tests in the big data world, right? Yeah, that's one thing I realized. MR unit I thought that was going to be huge, and then apparently nobody uses it. Yeah, of course, D3 is sort of the standard now, right? Yeah, there's this tool, Gephi. Have you ever used Gephi?
Oh yeah, Gephi's great.
Okay. Yeah, I mean, can you explain what it is?
Yeah, so Gephi is it's a Java-based GUI, so it's not web-based, but it's a visualization tool. It's been around for many years now. So there's the creators of that GUI actually for Java. They were Linkurious, and they created a web-based one. So it's not getting a lot of updates now. So it's kind of, I guess, legacy in a way. But it's used by a lot of data scientists to visualize graphs on their machine, but you need it to be in memory, so that's the problem. So if you want to make visualizations, you have to work on a bigger computer.
It's one of the few GUIs that have where you can sort of touch in dynamic graphs. So it's just awesome.
There's
Oh,
a lot
really?
of great features in there. Yeah.
Yeah, because Paco Nathan always talks about it too, and I didn't really know, yeah, why he liked it so much. Okay.
It's pretty graphs. It's nice.
Yeah. But can you, right, like how do you take them and put them in a notebook, or right, like how do you, right, like reproduce these things, you know?
They have different import plugins, but yeah, they have export plugins as well, so they have an ecosystem around it. So you can export them to a certain format, but that's about it.
Gotcha. And yeah, speaking of formats, right, like what are some of the standard formats for, right, because like NetworkX, when I was working with that, I was exporting out to GraphML or something, and then
GraphML is the standard, yeah.
That's pretty much, okay. Yeah, do you guys know of any other standards that are currently used?
Geth is trying to popularize this GraphX, GEXM.
Oh, it's their own?
Yeah, it's open source, right? Yeah, not really that many choices.
Yeah.
It's nice because then you can open it up in the project.
Right.
Yeah, as opposed to having to re-import when it crashes every time.
Yeah. Yep.
It's pretty, I think this is actually from Neo themselves, and of course they're in the upper right. So yeah, it like works out pretty well, but sort of, you know, graph processing, graph storage. I've never used FlockDB. Yeah, have you ever used that? Is that open source?
Not sure.
Okay. Real quick, some common like algorithms we've all used, we've all had to like memorize for our Facebook interviews, things like that. Subgraph clustering, centrality. Let's talk about centrality. This is the one I was like pretty excited about when I was out in DC, like learning about this stuff. So the first line is kind of the intuition, right? So there's the like classic degree centrality. This is, I think, the busiest slide I have. I could barely fit it all. Yeah, so how quickly can you spread info, right? So this is what we typically think about, right? Like in, right, like edges, or in like vertices, and then right, like out vertices. There's the betweenness. The way I think about this is, if you were to take that node out, how significant is that, right? Like to this whole graph. Closeness. Yeah, I mean, do you have a good definition of closeness?
Yeah, so closeness centrality is just a centrality metric that measures the average distance from each node to all the other vertices in the graph, or vertices nodes. But yeah, that's pretty much it. Uses single source shortest path, which is a metric for finding the average distance of each vertex to all other vertices in the graph.
Okay. And then yeah,
anyone correct me on that? It's been a while. I implemented it. I think that's pretty much the gist.
Yeah, and I guess the intuition would be, right, like how effective is a node at like communicating info to the rest of the graph? Is that
yeah,
kind of like what we're getting at there? And then yeah, my favorite, of course, is the obscure, the whole, right, like the eigenvector centrality. The way I sort of think, yeah, so PageRank is actually a form of this, right? Stochastic form of this. If you could kind of teleport yourself to some of the more impactful nodes, right? This is how you would do it. Yeah, basically have like the adjacency matrix, you like decompose it using eigenvectors, and then figure out what are the most impactful. Yeah, anything else there?
that's good.
Clustering, this is sort of, so if you picture, you know, triangle counting, the green here would be those known edges, right? And then we're sort of filling in the black, right? I think I have another diagram of this later on, but you could sort of, when you start to do some of these disconnected triangles, yeah, you could start to make, right, like small little inferences and say, well, maybe those two like might be connected. This comes in handy when we're doing recommendations, things like that. Yeah, the whole term, right, like transitive closures. You're like predicting potential like relationships between nodes that are not currently connected. And then, so we're starting to get it, you know, these terms are starting to become the machine learning terms, right? Clustering, we have classification. Yeah, basically, yeah, minimum number of splits to like divide the graph, right? So, yeah, right, like do you have anything more on here? Just trying to classify, see if these things can get like lumped into separate subgraphs there. PageRank, of course, this is the hello world of all of graph stuff, right? So we've got, this is the Python version. This is iterative. I'm not going to talk too much about Gremlin. This would be the, right, like graph-based version. It's a little bit tighter. If you think in terms of graphs and out edges and stuff, this actually makes more sense to you than like the iterative version here. So, okay, the exciting part, GraphX. There's no GraphX diagram or talk that does not have that logo. I don't know who created that, but they're very non-rich person. They're not making any money off that, but. So I didn't realize this until joining Databricks, like starting to pay attention to actually what was going on with each of these libraries and who was in charge and things like that. GraphX is actually one of the most under-maintained projects within Spark, and I don't really know why, except to say that the guy who sort of runs the project, this guy Ankur Dave, he for some reason refuses to go work for Databricks, or he just hasn't done it. I guess he actually wants to finish his PhD, right? So he's still at Berkeley, kind of chimes in at Spark summits and tells us all this cool stuff that's happening. There's a project that's called Indexed, RDD. And that basically gives you indexing into an RDD. So typically with Spark RDDs, you're just scanning the entire partition. But here you can actually go in, get point access, and that's sort of where all of the new research is starting to go. In fact, I heard Matei one day. I was walking out to go to lunch, and he was in a meeting and just joking let's just make everything a indexed RDD. He seemed kind of annoyed with this concept, but. It's just basically a way to get into specific data within there. So of course you need indexes and things like that. All of the recent updates pretty much have been to support Spark ML I guess it's still called MLlib. Things like LDA, when that first showed up on the scene, I think Spark 1.4, so that required changes to the Spark GraphX because it's using graphs beneath the covers. A couple algorithms, Pagerank. There's also personalized Pagerank that kind of snuck up on the scene. Have you guys seen this? So instead of the sort of global Pagerank, that we all think of, you can actually specify a source vertex and then go from there and then have it narrow it down. And it's just one parameter. I just found it one day by accident. I forgot. I didn't go back and look at when it actually showed up, but it's pretty useful. Sort of narrows down those calculations. Of course, GraphX has shortest path, degrees of separation, community detection, triangle. Down at the bottom, SVD++ for recommendations. I can't quite get this to give me the answers that I want. I don't know if I'm not using SVD++ properly. There's this really good book. It's Spark GraphX in action. Have you guys actually seen this? Has anyone? Have you? It's that Michael Malik. What's really cool about that book is he sort of steps you through Scala, at the same time. So I think it's chapter 3 where he's showing some code and realizes that it's totally obscure Scala code. So he actually diagrams it out and says, this is what's going on here. So I was joking with him. I saw him a couple months ago and I was that's actually a really good Scala tutorial in the context of graphs. So he just updated the book. I think it's not officially in print. I think it's on the final steps of the Manning. MEEP. Yep. But you can pull it down. I think it has about 10 or 11 chapters. And I sat down to actually create this presentation and start creating more and more graph type notebooks and things like that for my presentations, and just plowed through that whole book in one sitting. It's a pretty good read. And it kind of makes you think of things that you wouldn't normally think of, using graphs for recommendations. So graph frames, right now, this is the situation, mostly delegates to RDD. So that third bullet point about it's actually slower right now than if you just use straight up GraphX. So I think there's a couple native graph frame algorithms. I just mentioned, I think at the beginning about Spark 2.0, it's using the internal APIs, which is typically no-no, so this will probably end up becoming Spark 2.0. It's not Cypher compatible.
Not yet. There's plans.
Oh, are they planning it? But you can do motif queries, which is sort of Cypher-esque, I guess, right? You can kind of give it. So here, what we're doing, this is an example. We're saying, and pardon me, because some of the numbers are actually off. Don't think of V1 as being 1001. But basically, we're trying to find a disconnected, right, like triangle here, right? So we say find me v1 to v2. I have to give it an edge. Give me v2 to v3. Yeah, there's an edge. And then make sure v1 does not connect to v3, right? So yeah, the numbers are slightly off, which is my fault. But yeah, things like that are kind of cool. So I'll show some demos at the end real quick. Quick blurb about these. I think I actually didn't finish the one slide I was trying to finish. But if you picture this graph, right, so you have Toy Story, that's a movie, you have people rating it. So this is just typical by part type, right, where you have users and then you have items. You can then figure out based on coming in, right, like how many, right, like how popular this movie is. You can find other users that are similar to you based on the overlap. You could also add tags to this as well, or like genres, part of the Movie Lens data set, where you can start to filter these things. So yeah, you can get all of that sort of overlap between you and similar users, but like you don't necessarily, if you have a movie in mind that has a particular tag set, like you really want to filter out the recommendations based on how similar the actual items are to each other. That's the one that I didn't finish. And then, okay, let's do a couple, oh, sorry. Yeah, I heard a flash go off there. These are all be posted. Okay, so as part of, and then, yeah, I'm gonna finish all these on, or for Saturday's thing, of course, and then, but yeah, they'll be out there for everyone pretty shortly here. So this is, yeah, typical PageRank. Let me maximize this. So picture, right, like when I first started these presentations, I was all gung-ho about dating sites. Like, yeah, I'm on like 5 of them. I think about how they do things all the time, right? So this is your sort of typical like. So there's, you know, people liking other people. Right, like items in this case are also people, which is kind of weird. So here we're going to pull in our likes. I just have some sample data here, users. So this sample data is exactly these numbers, right? So we have, I think these are guys over here, the bald people, and then curly people are the ladies. So I've here, yeah, typical creating the graph. Here we're actually using D3. I snagged this from that GraphX in Action book. This, I actually, when I was talking to Michael at a meetup out in Denver, he was he was all excited about this. Yeah, I didn't know this, but you can actually call %HTML. The first I saw this was the Databricks Cloud product, which actually has something similar. It's called Display HTML. And then, yeah, Michael sort of introduced this to me where you can actually print this out. You're going to render HTML. So it's kind of complex, but you know, pass in your graph here. So this is a GraphX graph. Then it you know, goes in and it sort of scrapes it and builds up what like D3 needs. This is all D3 JavaScript nodes and links. You do some crazy stuff here. I've actually seen it too. Mine doesn't do it because I'm not that sweet, but you can actually, so this is the rendered version here. So these are, it's like the exact same graph that I drew out, but this is rendered by D3. I couldn't figure out how to get the weights in there for these edges, but yeah. And then there's ways to actually grab the nodes and kind of whip them around. Everyone loves that. I tried to get it working last night, and that was not going to happen. Yeah, like trying to do HTML on its own is, you know, pretty bad, and then trying to do it within a notebook and within all the stuff that's happening around the scenes. Because yeah, I noticed Michael's sample actually is a modified version of the most common samples that you see out there, and it's to sort of get around the whole Zeppelin model here. So doing the standard PageRank, sorting. I just put in some fake names, my ex-girlfriend there, me, Paco. Oh yeah, by the way, do you know that, yeah, is it Andreas?
Andreas Color?
Yeah, what's it, or is it, yeah, Mueller? Who's he's like part of Neo4j. He's like one of the.
It would be Andreas Collier.
Oh, is it?
Yeah. It would be the only Andreas there.
Yeah, he's in all the examples, all the Neo4j.
Except for the Andreas,
yeah.
the one who creates like.
Oh, really?
Yeah. That's why he's in all the examples.
Yeah, so he just got married, right?
So
Like
that'd
a-
be Andre's father.
Yeah.
There's like 4 or 5 Andres at Neo4j.
Is there?
It gets confusing.
Yeah, so I dated his wife. Yeah, which is why it's kind of funny. So yeah, super awkward. I've seen him at like Neo4j events, and I just kind of like duck and don't really say it because I think he knows who I am. But yeah, they're in Portland now, right?
That's fine.
Okay. So here's the personalized one. So this is personalized. If you guys know much about PageRank, there's this sort of dampening factor, right, that you apply so that you can converge. So what you do is basically there's a 15% probability starting from any single node that you would end up either going to some random node or just staying put. And then there's an 85% probability that you'll end up following your outbound network. So the whole intuition of this is if you're on a web page, this is where Larry Page got this from, you would be clicking just sort of random links, or you go to a whole separate page entirely, or you just wouldn't do anything. So that comes into play because what we're going to do is actually divvy up this 85% among all of the outbound links, right? So, and I think my source, so this is the personalized, my source is 1001. And we're trying to figure out who are the most influential people for this person, Tony. I didn't really do too much with the gender stuff, so you just have to kind of bear with me here. But yeah, Lisa, Cindy, that kind of thing. So that's all. Yeah, this is a really small data set. So yeah, some of these numbers come in a little bit goofy like that. Here's someone with no outbound links. Right. So again, 85% being divvied up across no outbound links. Yeah, there's gonna be a lot of zeros there, and then 15% staying put. So let's see. So that's exactly what we see. We see. That's not what we see. Yep, did this run? And just run the whole thing here. It's a pretty quick one. Yeah, so 1004 I guess is me. There's the 15 that I'm going to either stay put. Okay. Here's where we convert to graph frames. Does anyone use graph frames? Have you guys converted over? The whole idea is to sort of synchronize with the Spark SQL, right, like data frame stuff, right? So you can start to query it just like you would Spark SQL. At some point you can participate in the whole Spark ML pipelines, which is all right, like data frame driven. So yeah, you can do natural joins like you would think about in a SQL way. So I've converted PageRank now. I want to join it just like SQL so I can get the enriched version with their names like that. Same thing here. Data frames. Here's the guy with no outbound links, which I guess is me. Okay, let me pick a couple other cool ones. Okay, so this is Dijkstra, so we're going to do shortest path by cost here. So every edge is a weight. So picture Uber's trying to figure out, traffic or whatever. So the one I just skipped was hops. So to go from 1002 to 9002 would be 1, 2, 3 hops. So that's what would get returned there. But now we're starting to add in weight here. So it's actually cheaper to go 2, 1, and then down here than it is to go here to here. So yeah, this result's going to be different. Yeah, I snagged like Dijkstra from that book as well. I just didn't feel like it was just starting to remind me of interviews, and I didn't want to go through that pain. So it works pretty well. I put it in this helper class. That's part of this whole sort of ecosystem, the pancake stack. Okay, let me show. I think there's another cool one. If you guys have seen some of my prior talks, I actually make reference to this, and I kind of show a demo. I think I just show a screenshot, but this is where we're going to use this to recommend. So it's a Friday night. You're trying to figure out which movie that you want to watch, right? I like Message in a Bottle. right? Yeah, Andreas's wife likes, that's horrible. Yeah, scratch that. Yeah, likes Mad Max. And what's in common happens to be Waterworld, right? They share a similar plot, actually, which is interesting. And of course, they have Kevin Costner. And of course, I guess that's the worst movie. I don't think I've ever actually seen it to judge myself, but based on folklore here. What we're doing, so now this example, I'm actually using Movie Lens. And each movie has tags. It's in this goofy sort of pipe delimited thing, so you just have to parse it. And then each movie you can define by its tags. And then what we're going to do is pre-process this entire data set. And between each node, between each movie, we're going to define the similarity. And that's based on Jacquard similarity, which is for sets, right? So these tags are like a little bit wonky. They're not totally accurate. It was probably a million different people doing it, Mechanical Turk, something like that. But the more tags that you have in common, right, the more similar these things are. So yeah, those edges will be tighter. Which is good because then we can pipe it into Dijkstra's shortest path, right, that I showed before, which is going to find this pathway between these. So now this is a really small data set, so there aren't really that many paths, and sometimes the shortest path could be to the actual, between Mad Max and Message in a Bottle could actually be the shortest path. You wouldn't get anything. I got this idea. There's this project called Boil the Frog that came out of that group Echo Nest, which got purchased by Spotify. This guy did it for, I guess, a Echo Nest hackathon, where he was trying to do recommendations, and I guess the whole point was to recommend hipster things to hipsters, and sort of pop culture things to people that like pop culture, because I guess a lot of their recommendations started to cross over, and yeah, he was trying to find different ways. So he's got different ways to actually define similarity between these things, where he sort of dampens that relationship if it crosses over certain extreme genres, right? So for the movie example, you would probably maybe dampen horror, because there's a very people either really love horror or they don't, so you would want to sort of keep those people together. They're sort of the hipsters of movie land. Here's the data set using some slick visualizations here. I sort of briefly mentioned this, that we're doing this pre-processing. You see the word Cartesian in here. This should scare a lot of you. Anytime that you do Cartesian, this is a huge amount of shuffle. So here there's only maybe a couple hundred movies, but I think the actual data set maybe has 30,000 movies, something like that. So on small clusters, this takes forever. This basically doesn't finish, right? It'll just out of memory. For some reason, Spark 1.6, I'm still getting out of memories. They were supposed to fix this in Spark 1.5 or whatever, but it's probably something I'm doing. But yeah, Cartesian is bad. There's a whole separate talk that I have about approximations and this thing called locality sensitive hashing. This was something else I saw quite a bit at Databricks. Once people got a hold of their notebook, right, their Databricks notebook, and they were able to pull in this data, and they can scale up a cluster and not tell their boss that they're spinning up 50 of these huge Amazon instances. They started to quickly want to find similarities and do this kind of thing. And then, being a field engineer, I would get these support requests, hey, yeah, we can't get this going, what's going on? We talked to the data science group. Yeah, they came back. That was the first time I'd really studied locality sensitive hashing. What you do is sort of bucket. You pre-process all the movies up front, right? So that you're not doing a full Cartesian, but you're going to make one pass through and sort of bucket these things into horror, or if there's particular language, or maybe for movies, maybe where the movie was actually set, Chicago, New York, things like that. You might want to find some things there, and you can tune it, right, to figure out these clusters. And then you're just doing Cartesian within the actual buckets, right? So much, much smaller. So you're not doing 30,000 by 30,000. You're doing, right, 50 buckets of, right, and these items can end up in multiple buckets. right? So this is all based on hashing. So you go through, hash it out. You actually want to hash things together, right? Versus like a typical hash function where you're trying to evenly spread things out, right? Like you want similar items to actually end up in a similar bucket. And like you'll lose, some things that are similar, but yeah, you can tune it. So this is just straight up Cartesian. I do have a notebook on locality sensitive hashing. The code is pretty ugly, but that's because it's Scala, I guess. Similarity graph lays through here. Yeah, there's my attempt at doing D3 again. Okay, so I couldn't really reproduce my fun example with Water World, so I just took a couple of the ones that were in here. Yeah, I want to watch Toy Story. Girlfriend who's not the Andreas wife wants to see sudden death. How do we find something in between? So we run shortest path. We've pre-processed. We're just going to follow those edges until. So this is actually the way that this algorithm works is it's going to return that total cost from start to finish, and then give you, this is where we started. Number 1, that's Toy Story. This is what we went through. That's number 10. Ends up being GoldenEye, and then yeah, it's not returning the actual destination, but that's the code here. Start there. What's interesting about like GraphX stuff is that you sort of run Dijkstra on this entire graph, and then go through and then filter and just get the subgraph that you're interested in. So it's a little bit goofy because you have to kind of process the whole graph and then just find the from and the to that you're looking for in that path. And this is kind of the sort of intuition is that this, so that's 1 has adventure, sudden death has action, and GoldenEye has 1 of each. So it ends up with this tiny data set. This is the path that it took. With the Boil the Frog stuff, which you can actually go out, if you Google Boil the Frog Spotify, you'll see it. You can put in, like Lady Gaga, put in Metallica. It'll show 5 or 6 of these that are in between, and you can sort of reason through. One of my buddies from Dado actually extended this even more and started to include books. And then, so it was movies, books, and then music. And you can actually see that path and say, okay, yeah, that makes sense, that those would go that way. I don't think there's anything interesting here. Boom, 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 more D3. Yeah, I think that'll be it. Here's the SVD++ code. I've got it buried in the recommendations. This is actually right out of that book because I didn't want to do it myself. Yeah, that's actually from Netflix. Let's see. So now this is using graphs to find similarities, right? So sort of similar to what I was showing where you take all the users that are coming in, but some more some more decomposition going on. This is the one I can't seem to give it what I'm expecting. So it's returning values beyond my min and max. I say the min rating is 0, the max rating is 1 because I'm just doing likes, and it's returning 6 or something. So I have to talk to. Yeah, this is from the book here. It's pretty crazy. It's going to return the item factors, and then the user factors, and then that's how you can multiply and make recommendations. You basically take your user factor that's been determined by this matrix factorization or this decomposition technique. I have a vector of numbers. Each of these movies has a vector, and then I would basically have to calculate my vector against all of the movies and then sort, and then figure out what are my top recommendations. So it's pretty computationally intensive. Yeah, that's it. On Saturday, I think there's going to be about 100 people there. We're going to, just keep an eye on this. If you can't come, we're going to take one of these huge problems, and I think the last hour, we're going to hook up all 100 people into one huge Spark cluster. So, yeah, and then we'll try to do it that same calculation locally, you know, with the 8 core each. Yes, I'm getting right like. Actually, I think I'm going to go with the Google like cloud because I can get basically double the size. Yeah, I can get an 8 core 50 gig instance for the same price Amazon half of that, right? Where it's like 4 core 30. So it's going to be, yeah, we'll have 500. I have 5,000 gigs of RAM, and then yeah, roughly 10, yeah, and then 1,000 cores. So yes, either way, if you can't make it, just keep an eye out for that video. It's going to be awesome. Anything else? Any questions? Yeah.
To the extent that you can make this Cartesian, you might want to replace Dijkstra with A star or jump class search.
Okay. Yeah.
Because it'll be able to navigate.
Gotcha. Makes sense. Yeah. Any other questions? Pizza hungry people? Yeah, that's the worst when you're like, you can smell the pizza and you can see other people eating it. What's that?
Coding.
Yeah. Oh, yeah, you didn't eat. Yeah, let me give you the mic here, too. What's cool, yeah, Kenny's stuff is all Dockerized, too, right? So it's all up to date, so you could just fire it up if you want to clip that on. This is why they make hoodies, right?
Yeah,
San
right.
Franciscans love hoodies. Sweet, man. Thanks for coming.
Yeah, of course, man. Great talk. Should work. Okay. Oh, you're taller than me. There we go.
Got it? Okay.
All right, let's see this. Okay, how's everyone doing? Good? Good so far? Should I tell a joke? I might tell a joke. Okay. Why did the database have trouble ingesting data? Think about it. Think very hard. Ready? Anyone? Anyone want to guess? It had acid indigestion. Oh yeah. Okay, cool. All right, so I'm going to be talking to you guys about graph processing with Spring Cloud and Apache Spark today. So we're going to take more of an application-centric view of the world. So this is really going to be more about building these applications, integrating with Apache Spark. So thanks to Chris, we got really a good view of the internal world of Apache Spark. This is really going to be from the external view of building applications. Who's an application developer in here? Who uses Spring? Awesome. You guys are the best. Okay, so a little bit about myself. I'm writing a book, Kenny Bastani. I'm a Spring developer advocate at Pivotal. I'm writing a book called Cloud Native Java for O'Reilly with Josh Long. And this book is about building cloud native JVM applications and microservices, deploying them to a cloud platform like Cloud Foundry. So this uses Spring Boot, Spring Cloud, 2 application frameworks in Java for building microservices. So today we're going to be talking about an application that I built that ranks Twitter profiles using Pagerank. So it only uses one algorithm. It uses Pagerank, and it's incremental. And what it does is it discovers new users incrementally. So what it'll do from Twitter, it'll take 3 users as seed input. It'll import those users, and it's going to create a graph from that, which is going to connect these users together. Right? We're going to have edges that connect these users. One user might follow another user who one of the other seed users follows, and in that graph we'll run Pagerank. And then we'll take the top ranked user who's not in that the rank and run it again. So I'll explain all that with graphics. It'll be nice. Okay, so the Pagerank algorithm was first created by Google co-founder Larry Page. And so I'm just going to read this quote real quick, verbatim. The reason that Pagerank is interesting is that there are many cases where simple citation counting does not correspond to our common sense notion of importance. For example, if a web page has a link to the Yahoo homepage, it may be just one link, but is a very important one. This page should be ranked higher than many pages with more links, but from obscure places. So PageRank is an attempt to see how good an approximation to importance can be obtained just from the link structure. And so what does that mean? Okay, so here we have a graph. So we can see that we have node B, which is the most important node in the graph, or vertex, and then we have C, second most important. But the whole idea here is that we see a distribution of edges in this graph. So we see that B has the most incoming relationships, It makes sense why it's the most important node in the graph. But we see C here, that only has one incoming relationship, but it's from the most important node in the graph. So it's going to weight that edge, and it's going to be a vote that's going to give it a higher weight or a more importance than other nodes in the graph. If that makes sense. So we see here that at the bottom we have no, these purple ones, we have no incoming relationships, so that's why they're ranked the least in the graph. And so that's the idea. So if we apply that to Twitter, we can actually say that maybe our seed user is E, F, and D. Well, we're going to find other users on Twitter that have a higher ranking that are related to D, E, and F. And so what we're going to get is something like C or B. So it's going to scan and import these users on a regular basis, and then it's going to rerun PageRank. And so here's a beautiful screenshot of the application. Actually, I'm going to show you. I just deployed this to the cloud earlier using Chris and my boss, Andrew Clay Schaefer, who's not here. Anyway, so here's 3 seed users. I can add Twitter profiles here. And so once I add my first 3 users, this ranking dashboard here is going to be maintained. So it's going to import the users that are in between those 3 seed users from Twitter. And then it's going to do this on a schedule of every 15 minutes. And then it's going to run PageRank on those users. And so what we'll get is an incremental import from Twitter, but we're only going to import the users that are most important. Because of rate limiting, we can't go ahead and import everything and run PageRank, of course. And so that's why you would take this approach. So you can see Chris here at the bottom. He needs to up his Twitter game. I'm pretty close to the bottom too, at 44. And then I think Andrew's near the top, 23. So, does anybody know who Sarah Ray Chips is? Let's keep going down the list. Andy Gross? Okay, cool. So the idea here is that we're going to get a very relevant list of Twitter users. We all know who Adrian Cockcraft is, of course. And so that's the idea here. And so this is all open source. I use containers, Docker containers, and I'll show you what it looks like. Okay, so here is the architecture that I came out with. And so in the middle, we have the most important component. That's the Twitter crawler application. And that's running Spring Boot. Who's used Spring Boot? Great. So Spring Boot is an application framework from Spring that allows you to create JVM-based microservices. And so this Twitter crawler application is going to be importing users from the Twitter API here at the bottom on a regular interval. And as it does this, it's going to store them in the graph database there, Neo4j. And so the point here is that where the Spark comes in is over here. So this is what I like to call a graph processing platform, which is that you have your database. You don't have to do any exports manually to run any of the GraphX algorithms. What it's going to do is it's going to take the exports from Neo4j and it's going to process those and put them right back in. So we're going to be able to just use one interface here from the Twitter crawler application to be able to query that data. And to the left, this is a cloud-native application. So to the left, we have the front end there, which is the ranking dashboard. The Twitter crawler application is going to expose the REST API, which is going to provide all these operations for adding new seed users and getting the current ranking of all the users that are ranked on using the Twitter import. And then we have some cloud services. So the good stuff. Okay. So here's what I like to call a graph processing platform. So when I was at Neo4j as a evangelist, one of the big Stack Overflow questions that I tended to get was, why can't I run PageRank inside Neo4j? So this took me on a long journey, actually, because if you think about distributed systems, what you have to really think hard about is how much memory you have in an application, especially when it's a database. And so the reason why we don't have, or Neo4j doesn't have a PageRank operation is because when you're actually using analytics inside of a database and it's also operational, an OLTP database, you're going to be contending for resources. So you're going to be fighting for thread counts, you're going to be fighting for memory, and that's going to cause the database to maybe have some deficiencies when you query it for your OLTP use cases. And so that's why we have something called ETL, extract, transform, and load, where we're going to offload our processing for the analytics to something like Apache Spark GraphX. So to the left, we have Neo4j, which is our graph database, and that's going to, we're going to input a request to Neo4j, and that's going to include the algorithm type and the relationship type. So that algorithm type can be anything. It could be PageRank, it could be closeness centrality, betweenness centrality, but we're going to include a relationship type, and that's how we're going to get our export. So it's going to find all of these vertices in the graph that are connected by this relationship type. So once we submit that query, Neo4j is going to export a request to, or a message to RabbitMQ for the new job request. That's going to contain the information about how Apache Spark should analyze that data. And so as it does that, it's also going to export the definition, the subgraph, as an edge list to HDFS, where Apache Spark is going to pick up that new job request. It's going to run the algorithm that was specified in the job request, and it's going to import the data that's saved in HDFS. And so that kind of looks like this. So here we have our new job request that has the HDFS path that we exported our graph to, and that's as a CSV. And that's just going to be an edge list, which is going to be the ID of one vertex as it's connected to another vertex. And then the job type. In this case, we're going to use PageRank. And so what an edge list is just it's a very compressed view of a graph. It only gives us the relationships, the edges, and we can recreate just the shape of the graph using this edge list. So as you see here, we have a definition of this graph just stored as 2 columns in our export, our CSV export. So as I do that, Apache Spark is going to pick up that definition. It's going to import it in memory into Apache Spark. It's going to run PageRank on it, and then it's going to export the results back to HDFS. So it's going to have a new definition, which is going to be the results CSV, which is going to provide an ID and a value of the PageRank value that was calculated by Apache Spark. So there's this two-way integration going on. So as it exports that back out to HDFS, it's the same process. Neo4j is going to have a listener that's going to be listening for new messages from RabbitMQ, and it's going to load in that list from, it's going to actually stream it in so that it's taking a minimum amount of resources, and it's going to update the graph transactionally. And so that's the idea. Any questions on that? Let's do a demo. Okay, so now if you want to do this at home, I have an image called Spark Neo4j, which includes the Neo4j Maze Runner project. Actually, so you don't have to take pictures of that, I can show you what the repository looks like. So this is the Neo4j Maze Runner repository. And this is really just the core, this is the extension to Neo4j plus the Apache Spark runner. And I can give you a view of the architecture here. So we have an extension in here. That's going to be added to Neo4j as a plugin. And if we go to extension, we can see Maze Runner service. So this is going to be embedded into Neo4j as a REST API at /Maze Runner. And it's going to provide a couple REST API methods for submitting new jobs. And so that's the purpose here. And that's connected into RabbitMQ. So it's going to output new messages to RabbitMQ, which are going to be picked up by Apache Spark. The Apache Spark runner is mostly Scala for obvious reasons. And there we go. Okay, so in the algorithms directory, so this is all of the requests that come in are going to be routed to this algorithms module. And so we can see that I have connected components, I have PageRank, I have strongly connected components, triangle count, closeness centrality, which we talked about earlier. And so this is really the Spark part of it, where it's going to handle the routing that's coming in from Neo4j, and it's going to run that algorithm, output the results back to HDFS, and that's how we're getting this end result. So if I run this in Docker, so this is just a really ugly command. I'm actually embedding, who's heard of Docker Compose? So I've actually embedded Docker Compose in a Docker container, which is kind of meta. But that just allows me to easily just have one command rather than having to download the Docker Compose file. So if I run this command, which is up-d, provide my environment variables to integrate with the Docker daemon, I can go ahead and start that up. And then if I want to see logs, logs. I can see these containers are starting up. So that we see that the Maze Runner container is starting up. We see HDFS is starting up. And we see that Neo4j, the GraphDB, is starting up. So now it's available, and if I go to 192.74.74, so this is the IP of the container. So this is Neo4j at port 7474. And so now I have Neo4j running, and I can start submitting new jobs to Apache Spark. And so what I'm going to do to demo this, I'm going to create a movie graph. I'm going to do what Chris tried to do last night, but couldn't. And okay, so this graph, let's see the definition of it. Go to favorites, what is related and how. Okay, so this graph, here's the definition of it. So we have people and their relations to movies. So we have two labels here. These are the two types of nodes. So we can see here that in pink we have our people, and then we have our movies. Those are in gray. And we can see that we have a couple relationship types between them, like acted in, directed, produced, wrote, reviewed, follows. Now, what I'd like to do is to figure out which of the actors in Hollywood in this graph is the most popular to work with. And so I'll need to use Pagerank to do that, but I'm going to have to first mutate the graph. Because what I would like to get is, I'd like to get a GraphX port which connects two actors together. And because we see that there's no nose relationship or direct connection between these actors, we're going to have to create one. So we see here that Tom Hanks acted in some movies, and we see that other actors, well, mostly. Anyway, there's other actors who acted in the same movies as Tom Hanks. And so what I'm going to do is I'm going to run this cipher query here, which is to match all of the people in the graph that acted in a movie. So I'm going to get that path, but I'm also going to get all of the other actors, P2, that also acted in the same movie as the first line. And then I'm going to create a direct relationship from P1 to P2. So that's going to give me my mutated graph with the new relationships. So now if I query, turn P, P2, limit 20. Now we have this really messed up furball graph, but that's going to be very good for us to export to Apache Spark, because Apache Spark wants to see this kind of graph if we're going to run PageRank on it. So we have our mutated graph now, and what I'll do is I'll submit a new job to Apache Spark. And so what I'll do is Neo4j provides a REST API, a REST client inside their browser. So I'm just using this git command, and I'm calling a relative path to service Maze Runner, and then the analysis type, and I'm specifying PageRank, and then I'm specifying the relationship type, which is nodes. So as I do that, it should say success, and if I go to the log output from, I'm streaming the log output from the Docker cluster, and we're seeing the flurry of activity that you'll see when you analyze or you run the PageRank algorithm operation on data. So once this finishes, any second now. Okay, so we see here at the bottom that it finished, and it sent a new message back to HDFS. That's going to contain the result set mapped to each one of the IDs of the nodes in the Neo4j graph. So if I go back to Neo4j now, we can see that now I have PageRank stored directly on the node. So we see that Tom Hanks is the most popular person to act with in Hollywood, well, according to this graph, and then Keanu Reeves, Cuba Gooding Jr. So that's the idea here. So now how this works with Twitter is that it's going to do a very similar process. It's going to schedule new jobs with Neo4j, so it's going to talk directly to Neo4j, and it's just going to continue to run these PageRank jobs on a 15-minute interval. And as it does that, we're going to get an updated view of the graph, which we can then query to import more users from the Twitter API. Any questions? Cool. Oh, yeah, right here.
In terms of the Twitter graph here, the players are changing as in who's following who. That is that what's getting connected with the Pagerank against? So in case of movie database, we sort of built this in between graph of which actors know each other. So in terms of Twitter, what is that relationship? It follows?
Follows, correct, yeah. Yeah. So that's the idea. It's very simple. So we just have one graph, and it's all treated equally with that one relationship. Okay.
I noticed you did a manual step to convert the data back into HDFS.
Yeah.
Is it not possible to be able to write a plugin so that you complete the loop, or is the job complete a message and then trigger a load?
I'm sorry, I'm having trouble hearing you a little bit.
Sorry. So is it possible to basically complete the loop with the plugin to allow Neo4j to then load data off of HDFS once the job is completed in Spark?
That's exactly what it's doing.
Oh, but I thought you did a manual step and pull it back in.
Nope, no manual step. That was, I just queried the database. So it automatically, yeah.
Cool, thank you.
Yeah. Okay, so now let's take a look at the, so microservice. Who's heard of microservices? Okay, so when building microservices, it's important to remember, and I built this sample project for teams, engineering organizations, large engineering organizations that are interested in scaling their engineering rather than just increasing performance. And so it's important to consider that the reason why I've structured it this way instead of one monolithic application is that each team is going to work independently on each one of these services, and they're going to be able to deploy independently into production. So we don't just have one giant monolith where we have a lot of engineers working on the same application and then having to coordinate releases. So each one of these services can be deployed independently many times a day. And so that's the primary idea behind Netflix OSS, which Chris actually worked at Netflix and worked on some of these. And that's the idea behind me creating it this way. And so this Twitter crawler application is where all of the magic is happening. And it uses Spring Data Neo4j. So its way of integrating with Neo4j is we have a project in the Spring Data ecosystem called Spring Data Neo4j. And basically how this gets separated is that we have our repositories. And so in order for my application to be able to map the data in the database to objects in Java, what we'll have is we'll have a user repository, we'll have a follows repository, and then we'll have some custom Cypher queries that are going to be mapped to these repositories to pull in results to the application. So our domain model is pretty simple. We only have two entities. We have the user, which is our node entity or our vertex, and then we have follows, which is going to be our relationship entity. And then we're going to expose this repository, or three of these repositories, as a single unified REST API. And so here's what our domain model looks like. So we have our users who follow other users. So we can see that I'm in the middle here. We can see information properties that are attached to that vertex. So we can see that I have profile ID, and that's pulled in from Twitter. So that's a unique profile ID. We also have an internal vertex ID that Neo4j uses. So you can see that I am ID 0. And then we have our PageRank value. And then this is the same for all users that are imported. So what's costly is that when you're integrating with a Twitter API, there's a rate limit. And that rate limit, it's kind of hard to get around it. So the idea here is that we're going to have some users that we can import up to 5,000 at a time just by importing the edge list from Twitter. So Twitter lets you do that, but they don't let you import 5,000 users and all of their profile information. And so that's the idea here. These three users have been discovered, meaning that we've gone ahead and imported their user information and then up to 5,000 or more other users that they follow. And so for creating the Spring Data Neo4j repositories, here's my repository for the user. And we're just going to have a set of properties here. This is a basic POJO. And then we're going to use annotations with Spring Data Neo4j to describe how these objects in Java should be mapped to the data that sits in Neo4j. So the same goes here for the follows relationship. We're going to have a relationship entity annotation there at the top. I'm sorry if you guys can't see this. I'm very sorry. But at the top, we're going to have the relationship type follows, and that's going to pull in all of the entities that are the relationship between the vertices. So we have our user A and we have our user B. And then we have our user repository, which we're going to map our Cypher queries to. So if you can't see this again, I'm sorry. But the query here, the query annotation is going to have a Cypher query, which we can pass in parameters. In this case, we pass in the profile ID, and then we return back the internal ID that Neo4j uses. And so we'll have a set of these, and they're going to automatically be created as a REST API, which is a feature of Spring Data repositories. And so we'll do the same for the follows repository. So here, what we're going to do is, as we're importing users from the Twitter API, we're going to have these relationships between them. Now, if we had to do this with our database one by one, we're going to run into an issue, which is throughput. So we're going to have to batch these together. And so instead of actually just doing one by one, I've provided a Cypher query here which gets a set of followers or follow relationships, which has user A and user B. And what it's going to do is it's going to run a for each statement in Cypher, and it's going to go ahead and update the graph in a single query. So I can do up to 5,000 relationships here, another edge list, and it's going to update the graph in a single transaction. And so going back to the model here, so that's how this all works. So we're going to run PageRank on this, this interval, which is going to give us our PageRank values here. Okay, so exposing the repository APIs using Spring Data REST, that's really, really simple actually. I don't have to do any more work or add any more code. If I want to make my repositories a REST API in Spring Data, all I have to do is add a dependency here, which is Spring Boot Starter Data REST. And it's automatically, so Spring Boot's going to automatically configure the application to turn the repositories that we created into REST APIs. And so now when I call that endpoint, I'm going to get some hypermedia back, which shows each of these repositories and the link that we can use to contact it. So if I go back to the browser, where are you? Okay, so here's the ranking dashboard, but I also have the Twitter crawler application. So here's my REST repositories. I have following, I have tweets, I have users. And if I go to /following, now I can see a REST API that's going to give me back all of the information for all of my users that are connected. So I get back my edge list as an API. So this is all automatically done. Now my front-end application, I can easily just integrate with this REST API. I don't have to do much work. So now connecting to the Twitter API, this is where the Twitter crawler application has this HTTP connection to the Twitter API. This is where it's importing users on an interval. I add my dependency for Spring Social Twitter. And then I have to provide some environment variables here at runtime, which is the access token secret, the access token, the app secret, and then the app ID. And then I just map those to, so this is the Twitter crawler config Java. And actually, in the tutorial here, you can follow along. So if I'm going too fast, I apologize. I have to be somewhere later, actually, and you can go online, and I have all of this stuff laid out, and with each of the links to each of the classes on GitHub. So it's all available. It's all open source. It's all free. So please go and use it, and I'll post it to the Meetup page. So here, all I'm doing is I'm mapping those configurations, those properties for the app ID, the app secret, the access token, and the access token secret. And I'm creating a new template here. This is my client that I'm going to use. This Twitter template client is going to be used to actually call the Twitter API through Java and import users. And so here I have my receiver. So this is going to receive messages to import new users. So how I've structured this is that inside the Twitter crawler application, after a while, if the rate limits, you have no more rate limit left, what's going to happen in the middle of importing a user is you're going to be cut off. You're going to have a partial import. So you have to recover from that. You have to be able to self-heal so that when your rate limit returns, that you're able to finish importing. And so I've used a message-based system which uses RabbitMQ. And so the way that I schedule new jobs is in the same way that I schedule jobs with Apache Spark. I'm going to add a new job request to import a user. and then it's going to use that to import that user, and if it fails, it's not going to acknowledge it. So it's just going to be put back into the queue, and once that happens, it can pick it up later once it has more rate limit left. So for scheduling the new PageRank jobs, I'm going back to the graph processing platform here, where we submit the jobs directly to Neo4j. I'm just going to have one schedule PageRank method here with a schedule annotation, and that's going to be at a fixed rate of 15 minutes. So this is going to run every 15 minutes. It's going to submit a job to that endpoint that we looked at earlier, and that's going to schedule this new job on the follows relationship. So that's going to be sent to Apache Spark. It's going to be run, and then we're going to get our results back. And then we have our ranking dashboard, which is the last piece. And that's very simple. We use the Spring Zool proxy. So we're going to proxy the REST API through the front end. So we can actually have a JavaScript application that can connect to it. So if I go back to the UI, and I go to, should be embedded at, hold on, mappings. Can't believe I forgot it. It must be V1. There's a REST API embedded somewhere here. Do you mind if I pull up the code real quick? You guys don't mind, right? You know where to go after this, right? Okay.
Kevin, do you want to explain Zool?
Yeah, so the way that Zool works is that you can actually embed a proxy into each of your applications. So going back to this diagram here, Zool does a lot of cool things, but yeah. And with Spring, we have it integrated with, for Spring Cloud, we have it integrated with Zool. So we can embed a Zool proxy into each application. And so when we do that, we get something called an edge service, which is that we can embed the REST API. Let's say that Twitter crawler exposes the REST API. Well, I can go ahead and embed those directly into the ranking dashboard just using relative paths. And any request that comes into the ranking dashboard, it's going to be routed to the back end to that API. And so it's a pretty interesting feature to have if you're building JavaScript applications. Would you add anything to that, Chris?
Yeah, I mean, that's every Netflix service. Yeah, so every time you press play, it's going to Zool. And it has the historics component as well as the record component. Yeah. I think that was created 2 or 3 years ago. Yeah, I just keep filing that feature. And there's cool ways too where you can sort of like route like partial traffic. So just in case you want to start to debug things, you can still route it, but it's still going to like real production servers, but you can specifically choose like a subset of customers that you're trying to track, and then you can see what's going on. And sometimes that would happen where like a super high up would have a problem with their account. Yes, I remember this one guy, he was like some crazy VP. We could not figure out what was going on with his account, and then it took us forever to isolate it. But with this, we could have actually routed all customers, or just him, as this whole separate cluster, and we could keep an eye on what was going on. It turns out his roommate or something, or partner or whatever, logged into his Xbox and used his account, like the partner's account. And we also found out he was gay at the same time, which was kind of funny. Because we didn't know. So had we known that, that would have saved us about a week of work.
Thanks for bailing me out there. I got it. So I'll map that to Twitter-rank here. And so we can see the original API, which is 8081. Oops, 8080. So this is on a different host entirely. So this is mapped to a different port. And so we can see that I can just embed these into the user interface at a relative path of Twitter rank. Adam. 1 sec. Because most of you can't see that. So here's the path then we have. It's just / Twitter dash rank. So anyways, let's finish up. So for the ranking dashboard, I just have to provide some information about Eureka, which is our discovery service, and this is going to allow this application to be able to discover other applications in the cluster. So it connects to the discovery service, which is back here, the discovery service, and that's going to keep a service registry of all of the applications running in the cluster. And the way that the ranking dashboard is able to find the Twitter crawler service and to embed that API into itself is going to use the discovery service to do that. Adding the static web content is very easy. I just add it to my resources directory in the Spring Boot application. And this is where I have my JavaScript application that's going to call that embedded Zool REST API to get back the list of users that are ranked. I think we went through that. Okay, so going through a step-by-step process, once you run this application, you're presented with a blank screen here, and then you add your Twitter profiles. So I'll add myself here. That's the first step. And then I'll add 3 others. And once I've added those 3 users, we can see here at the bottom we have our ranking dashboard. So these users have been imported, their relationships have been imported, and now we're going to schedule a PageRank job, which will then also discover new users, import those users, and update this graph. And so over time, we'll see that we've added new users. So if I go back to the application, and reload, we can see that there are some users who were added in the last 15 minutes. And we can also see a delta, the change. So if a user went up in PageRank in the next step, then it's going to show an icon that shows them progressing upwards. And the same thing goes for users who have a lower PageRank on the next analysis. So they'll go down. And so that's the basics. If you want the GitHub URL, it's here. So I will put this on the Meetup page, and you can go ahead and follow along. I created a tutorial. God, it's hot here. Okay, so I created a tutorial. So if you go to my blog, you'll be able to see a full step-by-step walkthrough of everything that I just did. And you can take your precious time with it as well. If you're using Spring, I highly recommend taking a look. It's pretty thorough. And then if you have any questions, comments, just reach out to me. Yeah, so here's my information if you want to take a photo of it, and I'll take questions. Any questions? Sorry? Zool, what is it? Z-U-U-L? From Ghostbusters? The name was the dog in Ghostbusters. Yeah. He's the guardian.
Yes, I just want to make sure, right? So this was supposed to be like an advanced graph type thing, and we spend a lot of time on productionizing graphs, which this is really the first time that you see Spark GraphX being used in the production of setting things, right? So yeah, that part's cool, but I feel like there's probably still some graph questions that you guys have. Like you, for example, can you explain the comment that you made earlier? Just talk about the intuition a little bit about.
Oh, sure. And you were just mentioning that you were doing on a Cartesian plane. And it was interesting because there's this very fast algorithm called A-star, which works sort of like Dijkstra, except that it eliminates all the nodes that are going in the wrong direction on the Cartesian plane or Cartesian whatever. And then there's another version of that called jump cut, which looks for, and that's where there's blockages. And I don't think we have a blockage in this issue, so probably wouldn't help the A-star plane. It's just a thought. I don't know.
Yeah, but that's the kind of stuff I want to come out. Yeah. Can you explain something?
Yeah, I was actually just going to quickly ask a question about centrality. So, in general, in this type of processing, if I do want to write my own centrality and do something with it, is Spark the right place to do it then?
Sorry.
Not rely on Neo4j or something?
So the problem.
I come up with my own, division betweenness centrality.
Yeah.
And is Spark the right spot to work with that, or is Neo4j the right spot to work with that?
It would be in Spark, yeah. And so you can actually fork this project, the Maze Runner project. Let me just. So I showed you the algorithms earlier, right? So that's where you would add your algorithms. You would recompile the extension and then embed that into Neo4j and make a release. So the idea here is that Neo4j is going to be your interface. So you'll submit new jobs that way, and then it's just going to include the results back into Neo4j automatically. And so you don't have to do that graph processing inside of Neo4j. You can do it outside, but still have the results available.
Does Neo4j handle hypergraphs? Like if I have multiple edges between nodes, is that something that I can work with?
Yeah, through some graph modeling heuristics, you can use something called an intermediate node, which is going to create another node in between multiple other nodes. So you're going to replace that relationship with a node, and then you're going to have a triple there that connects it, that bridges the gap.
Okay.
Yeah. Cool. Any other questions? Well, thank you guys very much, and thank you, Chris, for having me.